Hello, this is Liv, and let's take a look at some scripts. Okay, so you've read the title, so you know what this is about. This is about SHAPEBAKE. What does SHAPEBAKE do? It says right here, it turns NLA strips into shape keys. So basically, this is baking animations, right? So this is all about baking animations. And when I originally released this script, it was for version 2.79 of Blender, right? Um, I'm not using that anymore, and I don't have a good way to test it without installing that extra version, and I hate having to do that. So, I'm giving you the code if you want to maintain a version of this for the older version of Blender. You can go ahead and do that. I'm giving you the code so you can do that. That's what I'm trying to say. So yeah, don't bother me about it, please. So anyhow, I'm just going to give you an overview of the code, in case that you want to work with this. That's kind of the point of open source. And yeah, I'll just give you a baseline idea of how this entire thing works. Okay, so this entire frag stuff. This is for when you want to do quantization of the vertex positions, if that makes sense. So what do I mean by quantization? Because you might understand that word to mean something different. Basically is to have this sort of like a PS1 look to the resulting baked mesh, right? Because we are going to bake all of the objects within a single collection into a unified mesh, so one mesh, and driving all of the animation from that collection as a shape key, right? As a set of shape keys, actually. So one shape key for each frame. And it's just nice to have that kind of filter for the vertex data. It's pretty simple. You just sort of clamp the position of the vertices to fall within a linear range. It's nothing out of this world. But anyhow, this is optional. If you set use frag to 0, it doesn't apply. Okay, so all right, and then just some functions to do that mapping of the vertex values to that linear range I told you about. And then basically what we have is a transferring of vertex data from a deformed mesh, right? So what we do is we take all of the objects, we apply modifiers, well, first we apply all of the shape keys that are active, right? So we apply the shape key mix of every object, we apply modifiers after that, and then we join all of the objects in the collection together. And then from that, on a copy of that, we transfer the vertex data, right? And so we need to use these functions for that. And I'm doing it with a vectorized version from NumPy. Like I think the performance gain is not all that significant, but just in case we can squeeze a little bit more performance out of that, I'm doing it. So anyhow, all right. So here's just a setup. You can read this later. Okay, and then just some boilerplate so that it can kind of still work for the older versions of Blender, but not really. Like going forward, development is just going to focus on post 2.8 API changes, because if I have to maintain both, it's going to fry my brain. Okay. All right. So yeah. And yeah, here we have some more boilerplate, right? So here we're not even using this function anymore. This is legacy, actually. So let me just mark it as such. Legacy. Here's when we apply the keys, right? So like I told you, we want to apply any objects we have that are shape key deformed. We want to apply those deformations because they might be part of the animation itself. This is not something a lot of people do, but it's something I do. So yeah, I would care about that. And yeah, and here we have more functions for applying deformation and modifiers and all of that. So here's the old way to do it, and here's the new one, which I absolutely hate. I mean, thank you, Blender devs, for all of your hard work. Like, I really appreciate it. And you know, this is a software that I will be using probably until the day I die. You know, I like Blender; it's good software. But a lot of the time, you know, I see stuff like this from, you know, like an API change that takes you from this into this, and you know, I'm kind of left wondering, you know, like Blender devs, what the fuck, you know? It's kind of like my catchphrase at this point. I don't know, you know, you likely you know better than I do about why this is better than this, but yeah. All right. So anyhow, here is the function that's doing most of the work. That's SHAPEBAKE. It's the namesake of the module itself. And basically, what you do to this is you pass an object, and from that object we say, all right. So let's take every object within the collection, right? So I realize that you can have an object in multiple collections, but I think that's a little bit stupid. So yeah, if you have it in more than one collection, then you know both collections are going to be used. So maybe you want to do that, and if you don't, then I don't know, like fix your hierarchies. I don't care. Anyhow, we take every object within the collection that is a mesh, and that it is visible, right? You've marked it as being visible, and you know it's not the original object because the original object will just be added anywho, and it's not already within the list, right? We don't want to have the same object twice. I hate duplicates. Okay, and so all we do then is we just select all of these objects marked for creating the bake. We duplicate, and then we apply all of the, like I told you, first we apply the shape key mix, right? So any meshes that you have that are being shape key deformed as part of your NLA animation, well, we apply all of that, we apply modifiers, and then we merge the entire thing. So we have only one mesh. Here's where the cool part comes in. So what will happen here is that this mesh at this point will be like the base frame, or more likely the, how do you say, more likely the T-pose. It could be the T-pose sometimes, some other times it could be the first frame of animation, it doesn't matter. But anyhow, and what we do then is, if I skip over here a little bit, what we do then is we start running through the animation frame by frame, and we repeat this little step of duplicating all of the objects, applying the shape key mix and modifiers, and merging them back again. The difference is at this point, what we have done effectively is we've applied modifiers at another point in the animation, and so what we have now is a baked mesh of the animation at that point in the timeline, right? So let me give you an example. So here we have a little animation I'm working on, and so you see, if I bake this, what it will give me is this entire character, a sword and all, as a single mesh, right? And this frame of animation will be a shape key, right? And if I go next frame, it will bake all of this, and all of this will be a shape key, right? But what we have at this stage is that baked mesh as a standard mesh. It is not a shape key yet, right? So how do we do that? This is how we do. We debug transfer, right? So this is the function that this is the function I showed you that was vectorized, right? So we have like two different functions, because I want one for when I want to do processing to get the PS1 look, and I have another one for when I want to do basically anything else, right? So just give me the mesh as it is, okay? And the way it works is actually kind of simple. You just, from your source mesh, right? So the mesh that we baked, we take the index of a given vertex, okay? And then from the shape key itself, right? So we are taking the shape block and indexing into its data attribute, which is basically a list of vector coordinates, right? So it is effectively that. It's sort of like a submesh within the mesh, if you like to think about it that way. So there are more attributes to a mesh than just its coordinates, but yeah, you know, we just want to write to the coordinates, and that's what we do basically. And so, you know, it blew my mind when I realized that I could do this. You know, because you can create a shape key, and then from a completely unrelated mesh, just transfer all of the vertex data, right? Or at least the coordinates, just transfer all of that into the shape key itself. And so this way we create a shape key from a mesh, okay? So you have your destination mesh over here, and you know, it has like a list of vertices, okay? And you have your source mesh over here, and you know, it's another list of vertices, but you know, in another configuration, so to speak, right? So you have your deforming mesh with all modifiers applied. You take all of this, oops, and you just insert it. Oops. Okay, so I wanted to copy and paste that, and for some reason that didn't work. But anyhow, you get the idea, hopefully. So yeah, you know, it blew my mind realizing that that was possible. But anyhow, and then, you know, we transfer all of that data, all of that deformed bit data, into the shape key that, you know, that we just created, and well, and then we just go into the next frame, and that's a wrap. And that's a wrap. So next up is just cleaning up all of the duplicates that the script has to do, because basically we are duplicating all of the meshes in the collection once for every frame. So yeah, it's expensive. If you couldn't already tell, this isn't exactly fast, right? So it's not exactly the most optimal way to go about it. I just do not know another way to go about it. So yeah, if you have any good ideas for improving this, you know, please tell me. You know, like it'd be nice. It'd be nice just being able to get this to work just a little bit faster. But anyhow, we have to do that cleanup, because again, I had duplicates, and you know, like, you know, reap what you sow. I have to clean what I've duplicated. So anyhow, then what is this? Okay, so this is, yeah, this is taking care of like lingering actions that might got duplicated due to the constant duplication of objects, something like that. Then what we do is we just create the driving animation itself, because again, we are just sort of like putting all of our animation data within an NLA script. We are taking all of that and just packing it into a single object, right? So single object, single mesh, and all of your collection into that object, right? And the animation is being driven by shape keys, and the way we have to do is you have, say, shape 0, shape 1, shape 2, right? And up here you would have bases or whatever. And as you might already know, shape keys are driven by this value that, you know, if you're doing relative is from 0 to 1, and if you're not doing relative, you get to say what the max values are. It's complicated, but we are doing relative, so it's basically a value from 0 to 1. Okay, so either do not utilize this configuration of vertices, or, you know, or use it, right? So the way you do when you want to drive this frame by frame animation this way is, and a lot of people don't know this for some reason, but what you do basically is say this shape N is the last one, like the last one in the list. And why do I have this? I will explain to you in a second. When we want to drive this thing frame by frame, we have to turn on the shape for the frame that we want and deactivate all others. So the optimal way to do this is to basically turn on, when we start, we turn on the first frame, and the last frame in the list, we turn that off, and the next frame, we turn that off. And then when we go to the to the next frame, we turn the first one off, the second one, I start counting from 0, forgive me, we turn this one on, and then the next one we turn off as well. And so doing this, you ensure that only the frame you want will be on at any specific time. And when you want to do the I had a nice format going in there. Okay, so when you want to turn on the shape, the last shape in the list, you have to turn that on, the previous one turn it off, and then the first one in the list turn it off as well, right? So yeah, this is how you walk a frame by frame shape key kind of deal. So I actually learned this like way back in the day when I was trying to do sprites, right? So I was trying to do sprites, and there wasn't like a very good way to do it. Like animating, animating a UV map was like not very optimal, or it was too difficult. I don't remember, but yeah, like it didn't work. It didn't really work. So I had to do it like this, creating one shape key for like every frame of a sprite sheet that I wanted. So yeah, anyhow, this entire block of code is just doing just creating an animation that does the thing I just described, right? So turn on the frame that you want and turn off the one before and the one after, right? So it's just that, and it creates that animation, and that's that. So a little addendum, if I will. There's the issue of the alpha, right? So a lot of the time, or maybe sometimes, you might want to drive the transparency of an object through its color attribute, right? So every object has a color. You might want to drive the transparency of some elements through that object color. So what we are doing, because because we are joining everything into a single object, we cannot use multiple alpha values anymore. So basically what we do is we just take the lowest one, right? So yeah, this is not the best. I will have to think of an alternative so that you can have basically the same thing you had with all objects separate, but with everything as one object. But anyhow, we can think about that later. It's like a corner case that we need to handle a little bit better. And oh yeah, and then we set the interpolation mode, and I've set this by default to be constant because I feel it's the best fit for this kind of animation. If you were trying to do like blending between one animation and another, like that's not going to work so well, right? Because you're just snapping the vertices into position. There's no bones driving that animation, so you have to go with constant. Though you can use Bezier. I don't know if that's how you pronounce that, but anyhow, you can use Bezier curves to like to transition between one shape key and another. Like it might work, but yeah, like I wouldn't even bother. Honest, I wouldn't even bother. I think constant is the way to go. But anyhow, yeah, we just set that, and that's a wrap, right? Yeah, and that's a wrap. So okay, So here, this last function is just the entry point into this, and it's just basically taking an NLA strip. Okay, it's just walking that strip and finding like all of the. Actually, it's not a strip; it's a track. It's an NLA track, and from the track we take the strips. And what is a strip? It is this lovely little thing in here, right? So you see, each one of these is a strip, okay? So it's basically an animation, and what you do is you put right. So you have like a timeline, and you put multiple animations, you know, one after the other, and we bake from this, right? So you say I want to use all of these animations, and it gets baked, basically. Now, what this will do is it will take the it will make like a list of the animations you have within your armature, because if you want to do this, it's because you have something deforming with an armature. Okay, so that was like the problem we had back then. I guess we still do have that problem, right? We don't have GPU deformed meshes, like you know, like that's too much. You know, I tried to do it once, and it was like fucking impossible. I mean, I got it to work, but it would crash my graphics drivers. So I said, well, fuck me, you know. Like I should try again, but you know, like I mean, UpBG code is so messy. I don't want to bother anymore, right? Because like I didn't mention that. So I developed this for UpBG, right? Because armature, the form is slowest molasses over in UpBG. It's like terrible. It's absolutely terrible. And so I just came up with a way to do it, and that's that. The forming this way through shape keys, it's much faster, like 100 times faster. No shit. And so because the idea was using armatures, yeah, the system sort of, you know, it's like a holdover from those olden times. But anyhow, it will take these strips and record the start and end frames, and then make like a little list out of that, and we can use that as animation data in order to set, you know, I want that animation or that animation, and you can just refer to them by name. But anyhow, everything that you have within your NLA track, into your NLA tracks, is going to actually be a part of the animation. So here I have some shape keys as well for the sword and all of that. Actually, let me see if I can. Let me see if I can mute this thing I'm working on here. Actually, let me just push it down. Okay. Like right there. Okay, give me a sec. I guess I want to show you how this looks. It's actually pretty cool. Okay, so we go up to 27. And I actually need to deactivate some shape keys over here. Okay. Alright, so let's I'll rename these later on. Okay. Alright. Okay, good. So just let's actually go full screen for this. Okay. So you see, we put the entire list of animations. So this is not an entire list of animations. It's missing some stuff still, like tags and all of that. I haven't thought it out entirely yet. But anyhow, as you can see, what we do is we put all of the animations for our character into a single list. But here's the thing, which I think it's actually pretty cool, is that you see this this thing we're doing here with the sword. This is a shape key as well. A shape key I did by hand actually. So that's why it's cool. So you see this thing is like a mesh, right? And you see, here's the trick. This guy has a attachment on his right hand. That's just the sword, but it's hidden, right? So he has like a copy of the sword without the sheath, and it's like basically being collapsed by this little shape key over here. And so what we do is here on the sheath, we don't actually have like the whole blade. We just have like this part, right? So the part that's going to be visible when we unsheath, right? And so it just does that, and then we just hide the thing. Actually, we have to do it like this, but and it has like a little movement in the air, like that's broken. I should fix it, but anyhow, this is just for demonstration. Anyhow, what happens is when we go to unsheath, so it plays like the unsheathing shape key, and then it hides, right? So it hides the blade side here, and it just unhides the one on the hand, right? But it looks seamless. It looks absolutely seamless. Like if I didn't tell you, you wouldn't know. Like, you know, if you knew me and my tricks, you would know, right? But you see, so yeah, it is actually a thing that I don't know anyone else that does this kind of shit. Like it's my trademark, you know, like unsheathing blades on like 900 vertex meshes, like low poly to the max, you know. Anyhow, so yeah, this is pretty cool, right? And this entire motion will be baked, right? Because we've put that into the NLA, and so this entire thing will play as we are baking, right? And so the entire thing that we have on screen is what's going to be baked, right? So, but instead of being like 3 meshes, actually 4, 5. Instead of being 5 meshes, it's going to be 1, right? So that's the gist of it. Okay. And yeah, we do get, but you know, even though we are considering like everything within the track, we are only taking like animation names from the armature itself, right? So because we have to pass this function on object, what it will do is just straight up say, okay, so you pass me an object, does this object have a parent? If it has a parent, it assumes that it is an armature. If it's not, then, well, you know, off you go, right? Like, it just dies. Yeah, you know, like, because I thought of this for using it with armatures, I never, like, bothered to fix that, but anyhow. It will record the start and end frames of all of these, and so whenever later on you want to skip to a particular animation, you already have the data in order to do that. So yeah, that was a long explanation, I'm sorry. So okay, and then it calls SHAPEBAKE and creates like a new collection and links the baked object to that. So okay. And oh yeah, and this another, yeah, but this doesn't matter. This is for cleaning up the generated object. Yeah, it doesn't really matter. So anyhow, let's see this thing in action, okay? Let me just rewind here. Actually, I don't have to. Okay, so let's save in case this destroys the mesh, because it might happen. Just messing with you. But anyhow, as you can see, this will take a while. Like, yeah, it's not the best. It's definitely not the best. But here it is, and if we go in here and we hide the original collection, we see we have a new collection with the .cr key, because that's like the format I made for 3D meshes, and so I've just slap it on everything I do, you know. And as you can see, this is a single mesh, right? It's a single mesh. It used to be like 5, now it's 1. Okay? And you thought I was kidding with the 900. I don't know if this is even 900, man. Like let's check actually. So let's see. Do we have what is it? Decimate. Decimate tells you. Oh, okay, no. So it's 2000. All right. All right. So I was kidding. All right. That's fine. That's fine. Let's see what happens if we decimate this too much. So it's nice. Do that. Okay, so 900. Let's get there. Okay, there we go. Perfect. Low poly to the max. And as you can see, if I stop messing around, it baked all of the animations, right? So let's take a look at what is driving this, and it is just this, right? So it's a long list of shape keys. If I just go in here, you can see that every shape key is one frame of the animation, and that's basically that. So if we play it, we get just the thing we want. Okay. I guess as a final note, I will let you know why I'm using this pixelated ambient occlusion thing, right? Like I'm going at one sample, right? Like hardcore, you know, like hardcore detail, you know. So anyhow, let me just show you real quick. So I'm going to render this out. And oh yeah, I'm not just doing like next gen detail with these one samples, you know. I'm also doing like super high resolution, you know, like 128. Yeah, like this will make your GPU go on fire, right? And you just go up in flames, you know. So now you see here, so this is what this is for, right? So if you look at it like at maximized, yeah, it doesn't look so good. But if you know, if you make it smaller, right, kind of nice. So yeah, like I'm actually using this. I'm actually making this mesh for a sprite sheet and not an actual 3D model. But you know, like it's what I had in hand in order to demonstrate the SHAPEBAKE. So yeah. I'm using it solely because of that. And that's a wrap. Yeah. Well, so anyhow, if you want to contribute to All We Live, which is the library I have, I started this forever ago and no one gave a damn. But you know, if anyone gives a damn, you know, like if you want to contribute, like you know, you can write code or you're an artist and you like to, you know, like give your stuff, you know, so that other people can work with it, you know. So like I'm going to be publishing this little fella when I'm done making the sprite sheet and all. Like this is going to be like one of the first things I publish to All We Live in a while. So what is All We Live? It is sort of it is a library of GPL assets for Blender, right? Actually, you know, it started out as an RPG thing, but you know, like we can go, you know, like beyond just a single game engine. You know? Like, this is just, it's tools for Blender that are GPL, and it's game assets that are GPL, right? And so for now, I'm going to be making sprite sheets and stuff like that because it's what I'm doing right now. But I'll be adding, you know, like more tools and stuff. So yeah, pretty cool. If you want to contribute or like browse like the very little stuff that we have, you know, come check it out. You know, the repo is in the link to the repo is in the description, all of that. But I mean, man, you simply cannot beat this look. It's amazing. I love it. You cannot beat it. Like, let me just zoom it out a little bit. Like, look at that. That is perfection. Place perfection. You get me? I love it. So alright, that's it from me. Have a good one. Bye.